Hello, folks. Welcome to Science Talk. I'm your host, Jim Massa. So, what are we looking at here? We got photos of the permafrost. What you can see here are ice layers or ice lenses, as it's sometimes called. They got one here. You have one here. Here's some more ice. And here's some exposed permafrost itself. And it looks like it's slumped a bit. You have some vegetation, some topsoil that's still in place right above the ice, you notice, kind of creating like a little insulatory cap. So got some slumping here. I don't know if it's totally oozy or not, like what's called liquefaction, but there's definitely some slumping that took place. And to give you an idea of the size of these things here, here's a gentleman standing here, and you can see how big they are. What are we looking at here? This is a blog by Samuel Hayes. I'm presuming that's him in the photo. Investigating the eroding Arctic coastline from net weather to Tuktoyaktuk. Tuktoyaktuk is, I will show you in a moment, is a settlement right on the Mackenzie River Delta. So he recounts his travels in August of 2017. He was in the Western Canadian Arctic in a small hamlet along the Arctic coast called Tuktoyaktuk, which folks just call it Tuk. And it translates, looks like a caribou. The folks who live there live a subsistence way of life. So they hunt, they fish. Small community, no cafes, no bars, restaurants, hotels, and so on. Okay. Tuk has been gaining investment from the Canadian government as a key location when it comes to Arctic geopolitics. In fact, it got its first connecting road just 2 years ago, finally linking to the rest of Canada. Now, I used to go up there a lot, and when I was there, there was no roads. I would go up there summertime, wintertime. Wintertime, you see this, you see vehicles, including heavy tractor trailers on the Mackenzie River. Think ice road truckers. Tuk is also a major base for Arctic research and offers an access point to many areas of interest to polar sciences, such as sea ice in the Beaufort Sea, right there. You got beluga whale habitats. The Mackenzie River Delta is right here. And eroding permafrost coastlines. You can see some of the other major lakes here, like Great Slave Lake, Bear Lake. There's little Fairbanks there. So here's Inuvik, right there. And when you blow this up a little further, and here's Inuvik there. It has a small airport. You used to fly into there. This meandering line here, that's the Mackenzie River. It's got some offshoots here. Right, it's a little branch that comes off. Some of it goes this way, but the main branch goes to here. Here's part of the Mackenzie River Delta. Here's some other deltas as well. And there's the location of Tuktoyaktuk. And there's the thriving metropolis. That's what it looks like. You'll notice how very low the elevation is. If you're losing coastline, and if you're losing sea ice, you don't have the ice protecting what coastline remain. You now get storms. You're going to get storms just battering the crap out of the place. And when you batter the crap out of place, you're battering coastline. You're going to erode the coastline so that you get chunks of coastline falling into the ocean. And that's basically what we're going to be discussing here. The collapsing Arctic coast. Okay, so why are they eroding at such a fast and accelerating rate? So what's some of the physical properties? Many of the coasts in this region consist of loose sediment bound together with ice. So ice provides a rigid structure, gives the soil strength. However, if you melt the ice, then the soil loses cohesion. This causes it to slump, slide, and collapse. And then the waves do the rest. The vast majority of the erosion occurs during the summer and early autumn when the sea ice has retreated, snow cover has melted away. When sea ice is locked in place, the coasts are largely protected from erosion. So any increase in the open water season length will cause substantial increase in retreat rates and increase the erosion rates. Couple that with how fast the Arctic is warming, how much sea ice is being lost, how it is freezing late in the year, melting early in the year. The volume of multi-year ice is rapidly declining. Couple that all together with the warming temperatures, and you've got a recipe for disaster. And here's a sampling of some of the headlines: collapsing Arctic coastline, relocating the village in Newtok, Alaska due to coastal erosion. That's one of the villages that got moved in several miles inland. I mentioned that. I mentioned this sort of situation in earlier videos. Severe Arctic Ocean acidification via permafrost thawing and river runoff there. Now, that's an interesting thing because when you look at the soil, the pH of the soil, it tends to be on the acidic side. So now if that is, the permafrost is thawing, the ice within is melting, and now you get all that material washing into this ocean, you're going to be decreasing the pH. You're going to acidify the ocean. So that's one of those ramifications a lot of people don't think about, but it is happening. And that is something to really think about. One of the things, when you look at, say, the little black spruce trees in the taiga that grows, it takes about a century to grow, some 30 centimeters or so. And, they're in the permafrost. But if you look at the content of the permafrost, poor nutrients, very low pH, so it's highly acidic, you can see where that comes about. A fascinating aspect of permafrost erosion are the two unique types that occur along Arctic coast. The first is block collapse. This is a process whereby waves and swells eat into the base of a cliff, both by thawing the soil with warm water and then breaking it down with wave energy. So you warm it up and then you punch it into oblivion, basically. This results in a notch extending into the base of the cliff, eventually causing the overhanging block to collapse. This form of erosion is associated with some of the fastest retreating coasts, especially in Alaska. It is relatively well understood. So, what are they talking about here? Okay, see how this little bit of land juts out a bit? And you see how when you go underneath there, it goes further back inland. That's what they're referring to, cutting into, making a notch. So you got the warm water, you got wave action, it cuts into this, and eventually it will just collapse from its own weight, as we see here. And that looks like it fell off from this portion there, just tumbled over. And this is ice. That's ground. This is ice, more ground. Here's some more ice. There's some ground there. And to show you the scale of this sort of stuff happening, there's a researcher for scale. And you can see we're not talking about little itsy bitsy pieces of land. We're talking huge chunks of land that's just dropping off. So both of these photos come from block collapse in Alaska. The other form of erosion is called retrogressive thaw slump, usually just called thaw slump. These feature dramatic looking C-shaped scar zones that can be up to 1 kilometer across, capable of extending inland by over 50 meters in a single year. They transfer vast quantities of soil into the nearby sea, lakes, rivers. They feature another unique characteristic of permafrost soil: thick layers of ice within the soil, known as massive ice bodies, ice lenses, different names are applied, When these ice layers become exposed to external energy fluxes, they start, okay, the ice will melt, the permafrost thaws, the soil will thaw. Okay, so then the permafrost soil will start crumbling, mixing the meltwater with the thawing ice layer, or melting ice layer, the thawing permafrost, and then you get these large mud flows, which is called liquefaction. The size and number of these slumps have grown dramatically in the last few decades. And he cites Banks Island, that in 1984, only 64 thaw slumps. By 2015, increased to more than 4,000. So in the scant over 20 years, 64 thaw slumps to over 4,000. That is an acceleration. By 2075, an additional 10,000 more are expected to form each decade. So this is an example of the thaw slump. You have a thin permafrost line here. Here's your ice layers. You got permafrost right here, right? And this is the mud flow. This is the liquefaction right here. Slightly lightly colored, right? This lighter color is the mud flow because it's mixed in with water. And then, so this is an overhead view. This is more ground level. You can see the ice layer and you can see the mud flow. So the question becomes, okay, what's the point of studying this? Well, people live in the Arctic. I mentioned how a whole village in Alaska had to be relocated. This is going to affect people's homes. It's going to affect the infrastructure, the roads, the buildings. Recently in Siberia, there was a huge oil spill of some 10,000 gallons because the tank that the oil was contained in was sitting on the ground, and the ground gave way due to, you guessed it, the permafrost slumping away, and then the tank split open or tipped over or both and dumped the contents. I did a video segment some time ago talking about the effects of permafrost thawing on settlements within the Arctic community. Sediment transport from thawing, eroding permafrost is changing the nutrient balance, affecting fish species, promoting algal blooms, increasing ocean acidification rates. So much carbon is entering the shallow sea, excuse me, that during the coming century, large parts of the Arctic Ocean may switch from being net carbon absorber to an emitter. Translation: right now, the Arctic is a carbon sink. It's changing over to becoming a carbon source. And as I mentioned at the outset here, with concerns for Tuk, erosion of the island that has historically acted as a protective barrier will leave much of the village exposed to powerful Arctic storms, further increasing land loss for the village, destroying homes and property. So, yes, we need to understand what's going on. So here's a projection of what's going to happen by 2050. All this is, they didn't put a scale here, so can't really give you an idea how much estimated coastline loss that is. So let's see. So this person here is a researcher in this area. So they talk about some techniques and technology they're using to better analyze and study the permafrost, the dynamics, and so on. So they look at, they make 3D surface models so they can look at the variations in the ground surface, such as slope, angle, elevation, and how these influence slump activity, coastal retreat rates, other processes. And they use a what they call structure from motion approach, which is based on the principle if you take photos of an object from different angles, you can reconstruct this 3D geometry. And so they basically fly drones around, taking shitloads of photos, and then dump it into a computer program and reconstruct things. So as you can see here, right here's some more of that mud flow right here, the lighter color uh, aspect. Here's some ice, some of the slumping ground. Here's the gentleman there. Now, one thing they want to do, they wanted to map the ice layers without what they call using invasive methods like boreholes. Because when you drill a borehole, okay, yeah, you can get down in, you can stick a camera in it, but guess what? You have now removed a cylinder of material, and you're now allowing heat to get into that hole, however deep you drilled it. And that does not help maintain the integrity. You put in the heat in there, you're going to actually accelerate the thawing of the ground, the melting of the ice. So trying to avoid boreholes is a good idea. So he describes this device called a tromino that measures naturally occurring seismic noise. By analyzing the seismic signal, it's possible to detect the subsurface layering, such as how deep the ice is, how thick is the overlying permafrost, and that's all very important information. So he's got a picture of this instrument here, and I can't. I think it says frequency. I think that's in hertz. I can't really. He does not explain what HV is. So I can't really comment too much on what these graphs are telling us because there's nothing in the body of the text explaining this. Looks like he's taken north-south component, east-west component, up-down component. Again, I'm not sure what the information being conveyed here is. He talks about other gadgets, such as using an Iver, which is an autonomous underwater vehicle that can operate in oceanic and fresh water, and it can basically monitor sedimentation flows, all sorts of things to gather all sorts of information. Thermal camera imagery, time lapse camera, etc. There's a lot of cool tools that we have. Okay, eroding Pingo. Tuktoyaktuk is surrounded by Pingos, even has a national park called Pingo National Park. What are Pingos? Pingos are, when you're on the Arctic ground and you walk around, you see like basically looks like flat terrain. Then you just see these mounds. The mounds can be, several meters to, across to several hundred meters across. They can be, several meters tall to hundreds of meters tall. And basically, it's just the mound is filled with ice. That's what it is. Mounds are filled with ice. The mounds of ice that grow just a few millimeters per year, reaching heights of dozens of meters or more. I've seen them. So Tuk has the second tallest Pingo in the world at 49 meters. Okay. That's about 150 feet straight up. Well, actually, a little more. So they're big. The ice inside these Pingos can be quite spectacular and freshly exposed, have all sorts of colors and patterns. That's kind of cool. But because of the high ice content, they can erode very quickly once the ocean reaches them. And then they may be gone very quickly. Now, in some cases, the ground will slump into now the cavity that's left behind, and then that gets filled in with water, and you get what's called a thermokarst lake. Now he talks about Pelly Island on the northern edge of the Mackenzie Delta. It was a site furthest from Tuk that they went and examined. And this goes back to a photo earlier, but this is large chunks on Pelly Island. Okay, so what do we got here? We got some aerial views now. Fine permafrost landscape, you get some interesting looking landscapes. Okay, so you fly over, okay, In image A, this is a Pingo right here. That's a Pingo. B shows some thermal karst lake, okay, that I just mentioned. It's, for the thawing permafrost lake, that's what they call thermal karst. Usually it's filling in after the Pingo collapses. And then C is a polygon structure formed due to the presence of wedge-shaped bodies of ice. That's this right here. And kind of interesting. Sometimes you see like hexagonal shapes. It's really interesting how these form. But these are some of the interesting landscapes you can find in the Arctic. So he talks about some of his research that they've been doing. One of the most novel findings was the passive seismic data actually works, so that it enables them to gather more information with less invasive methods, which is good. So we got 20 meters scaling here, and presumably you then reconstruct matters, and you've got thick ice layer, shallow overburden. That's the permafrost over the ice, and so on. So they're using all these tools to reconstruct what the ground looks like. And then once they have basically baseline data, they can keep monitoring it, note the changes, make the computations as to what's happening, and then determine the rate of erosion, the rate of melt, the rate of thaw. I think you get the idea. So you've got some more, looks like a time series going on here from 1 through 5 years. And we start here. Okay, here's the ground. And you'll notice it's gone back a little bit here, right? See how this went back here? Then it went further back. And now we've got, this protruding shoreline, probably from mud flows. And it just keeps going out and out and out. So there's some interesting research here. He talks about one of the most unexpected findings that the rate of coastal retreat on Peninsula Point had slowed in recent decades, which is contrary to expectations. Throughout the 20th century, there's widespread layers of ice up to 10 meters thick. By 2018, the ice was typically thin, patchy, with a maximum thickness of just 3.8 meters. This led to the conclusion that a reduction in ice has counteracted the warming climate, slowing rather than accelerating the coastal retreat rate. This is another important finding. This is another finding with important implications for other regions with these thick ice layers. Does the thick ice persist inland? If not, the coastal retreat may slow. If it does, the retreat may accelerate. So they need to, sounds like they haven't quite figured out the mechanism for that, but they have an idea. They're testing some hypotheses for that. So he's finishing up his doctorate here, I guess, because he had to return to Inuvik via boat through the Mackenzie Delta on the final day. 5 hours is during sunset, and because of the curvature of the Earth and high latitude, sunsets up here in the Arctic can last for hours. It's really quite cool. Whenever I travel to mid latitude, I see the sun starting to set, and in my mind, I'm thinking, "Oh, I've got a couple of hours before before it gets dark." And then, like 10 minutes later, it's dark. It's like, "Oh yeah, right. I'm at low latitudes." So I've gotten so used to the extended sunsets, and for that matter, sunrises, especially during the winter time. It's really quite pretty. So here's some photos of it, and these are spectacular photos. See, like this one here in the lower left. And this is the wake from the boat. But, yeah, there it is. Some beautiful colors there. So if you're interested in, I was not going to go through the entire an article here because it is very lengthy. But if you're interested, you can go to netweather.tv/weather-forecast, and then you can just look for, type in the search net weather to tuk toyaktuk, and you can then pull up this blog and look at this in more detail. But I wanted to share this with you because the eroding Arctic coastline is a major problem. Losing chunks of coastline just falling into the sea. This has implications for any human habitation that are found nearby. But as we learn, since the permafrost soil tends to be acidic, you're dumping acid into the seas, you're changing the pH of the sea, which will then have its own ramifications for the marine ecosystems. So there's another aspect to it. And of course, wave battering, ground falls in there, you're going to release more methane. And this is happening because the sea ice is basically disappearing. No protection from the coastline. The sea ice is disappearing because of the warming planet. So you have warmer waters beating at the shorelines. The ground juts over. Eventually it collapses under its own weight. But you have all these dynamical processes happening. And it's all related to how we're changing the climate, how we're changing the balance of things. So netweather.tv /weather-forecast from netweather to Yaktuk. Hope you found this interesting. Thank you for your time. Hello, folks. This is Jim here with Science Talk, asking you to please subscribe to my channel and to inform others of my channel and of the work that I do. Please share to social media platforms that you use. Also, as a reminder, don't forget to click the bell so that you know when I load up more videos. Finally, I ask that you support the work that I do by becoming a patron at patreon.com. Details in the description box below. Thank you for your support.